First, I have a couple of housekeeping points. Please note that this session is being recorded and ensure that you have read through the JJI Code of Conduct and the policy for virtual events. Please ensure that your microphone is muted unless we ask you to speak or the presenter asks you to speak. We will be circulating some registration and feedback forms, so we will be very grateful if you could fill those in. And please introduce yourself in the chat box and add your name, your role, and where you're from. In this session, you can ask questions using Slido. So please log into slido.com and the session number is 037627. We will put that number on the chat and you can add questions as this session goes along. So the Jim Golding Institute is the central hub for data science and data-intensive research here at the University of Bristol. We are one of 5 university research institutes, and we connect a multidisciplinary experts throughout the university and beyond. The Jim Golding Institute collaborates with national and international partners, for example, with the Strathmore University in Nairobi, Kenya, who also spoke during Data Week, the Institute of Statistical Mathematics in Tokyo, Japan, and with national partners such as the UK National Data Science and AI Institute, the Alan Turing Institute. We offer a range of events, training, funding opportunities, and coordinate a data science consultancy service called Ask JJI. So if you want to know more about all the opportunities for networking and support, please log into our website, bristol.ac.uk Golding. Here you can have an overview of the events of this week, color-coded, seminars in yellow, training in blue, and workshops in green. And I hope you have enjoyed some of those events. And please, I hope you can join us on the networking session today at 1 p.m. And we are going to showcase some of the projects that the JJI has funded at 3 p.m. today. And if you're interested in funding for projects, I recommend you to attend to this event, as it will give you an idea of the types of projects that the Jim Golding Institute can fund. We couldn't have organized and delivered this amazing data week without the collaboration of our partners and collaborators from internal and external. So thank you so much. And I hope you can keep in touch and we continue this conversation. So please join us at Twitter at JJI Bristol, #Bristol Data Week. You can also look at our blog and news. And you can also receive our newsletter. So sign up for the newsletter. We send that once a month. We also run a data ethics club every 2 weeks, and it'll be great to have you there. And you're also invited to our next big event, the Jim Golding Institute Showcase on 2022 on the 17th and 18th of February. We're hoping that this is going to be our first face-to-face events in the M Shed, which is a flagship museum here in Bristol. It will be a family-friendly event open to the public. We'll have inspiring speakers, exhibitions, workshops, art, and it will be an opportunity to connect and socialize. So I hope you can be there. And if you like to showcase your research, please get in touch and we can discuss how we can do that. So I'm going to stop sharing. And now I'm going to share with you, let me see if it works. So we have a little bit of a, so this event, as you know, is to talk about opportunities to join the BSc in data science here at the University of Bristol. And we're hoping that Professor Christopher Andrew will be here with us to talk about the BSc. He has some internet problems, which is trying to be fixed. So we're going to show a video of Christoph talking about the BSc. And then he's gonna have, hopefully he can log in now then, and then respond to some of the questions. So I'm just gonna try to get, oh, I think Christoph, are you here actually? because now I cannot share my screen.
Hi, I'm here. It's working.
It's working. Yay!
But let me see if the presentation is on the computer. And yeah, there's still someone working. So.
All right, Christoph. So if you want, because you just joined in, I cannot share the video, so you have to make me host again.
Sorry, I can't hear you very well.
You need to make me host again.
Okay, sorry. Yeah, should be okay.
Great, thank you.
Hello, I'm Professor Christophe Andrieux, and I'm going to tell you more about our new and exciting BSc program in data science. From next year, we will be running a new BSc in data science, which comes with the option of an intercalated year in industry. Data science is a relatively recent but already well-established discipline at the intersection of mathematics, statistics, and computer science, and aims to make sense of data. Trying to make sense of data is not new, but the scale and pace at which this must be achieved has changed and led to the realization that the solution to this new challenge was interdisciplinary. Employability prospects in data science are extremely strong and set to last. This BSc is a direct route to a wealth of diverse and exciting careers. What is data science? Well, the world generates and stores vast volumes of very diverse data which touches on every aspect of our lives and environment. Making sense of this data deluge has the capacity to be transformative. For example, the data gathered in smart meters in your homes can help address the intermittent nature of renewable energies. The analysis and interpretation of data is playing a major role in the management of the current pandemic. I encourage you to watch the video clips by Dr. Matteo Faziolo and Dr. Dan Lawson on those topics on our website. Making sense of data is a highly challenging task, but it is now understood that this can be addressed through the interactions of mathematics, statistics, and computational methods, leading to the emergence of this new branch of science and technology. Traditional degrees do not offer the coherent and consistent coverage of skills and knowledge required to take part in the data revolution. In contrast, data science programs are designed to equip you with the essential skills and knowledge required of a data scientist in an integrated fashion. A rapidly growing number of universities worldwide now offer such programs. At this point, you may still not be sure about what type of degree to choose. A data science degree is definitely for you if you're interested in understanding the sophisticated theories and methods of mathematics and computer science used to extract knowledge from data. But at the same time, you are also interested in the opportunity to have an impact on society or business and participate in the data revolution. In fact, this is an opportunity to become a sought-after expert and benefit from high employability prospects. A degree in data science offers the right balance of breadth and depth in the relevant areas of math and computer science, not offered by degrees in mathematics or computer science. Why choose Bristol for a degree in data science? Well, the environment is certainly an attraction. Bristol is a vibrant city offering an excellent quality of life. The School of Mathematics is located in the Fry building, which is at the heart of the campus and was recently fully refurbished. You are encouraged to take a look at the virtual tour of the building on our website. Academically, Bristol has one of the top 5 schools of mathematics in the UK in research and boasts a diverse and friendly math community. Perhaps more importantly, great care and effort have gone into the design of the degrees. For example, a large number of units have been specifically designed for our new degree in order to offer a coherent program covering all aspects of data science and will be taken by students on this degree only. These units come alongside core and relevant units from our existing curriculum. Some of the units are delivered in collaboration with the interdisciplinary Bristol Scientific Computing, also known as BRISC, which aims to train scientists in those areas of computer science directly relevant to them. The School of Mathematics and Faculty of Science have put substantial effort in recent years into strengthening links with industry to facilitate placements, and it is worth pointing out the vitality of the tech scene in Bristol, which offers numerous opportunities. What do our degree look like? First, we offer two versions of our BSc in data science: a classical 3-year full-time BSc degree, a 4-year BSc degree with an intercalated year in industry during year 3. What will you learn? The main goal of the first 2 years is to introduce you progressively to modern ideas and techniques of data science, including machine learning. This requires building rigorous background in the relevant foundational areas of mathematics and computer science, which will allow you to acquire a deep and coherent understanding of the discipline and deploy your knowledge and skills with confidence. The number of contact hours in the first year is similar to that of the other math degrees, about 19 contact hours per week in year 1, but involves computer labs for some of the bespoke units. The first 2 years were designed in such a way that you would be ready for the intercalated year in industry, if you choose this option. In your final year, you can choose from a large number of more specialized units. This is what the units in each year look like. The last year is labeled 3 or 4, depending on whether you are on the degree with intercalated year or not. The black units are existing core units. The blue units are in collaboration with the Bristol Scientific Computing Centre. The units in red are bespoke units, especially designed for the course. For example, in year 1, the Mathematical Tools for Data Science unit builds on some of the notions taught in analysis, but takes the ideas further, leading, among other things, to the mathematics and algorithms of optimization. This is fundamental in data science, and in fact many other disciplines, and traditionally not covered or covered much later in traditional curriculums. Other examples in year 2 are advanced linear modeling and classification, and algorithms and machine learning, where you are taught advanced machine learning techniques building on the theoretical and computational material covered earlier. Perspectives in mathematics involves, among other things, making you aware of the legal and ethical issues surrounding the use, storage, and processing of data. In year 3, you have great freedom to choose from over 15 units relevant to data science. You can find the full details of our degrees by following the links from our BSc in Data Science webpage. The University, Faculty of Science and School of Mathematics have put significant effort in recent years into strengthening links with industry. We have strategic partners, the most relevant are listed here, and a growing list of companies more closely associated with the BSc in Data Science. You can find interviews of some of our partners on our website under the BSc webpage. Career Service will help you explore career opportunities through your time in Bristol. What happens after a U degree? Well, data is collected in virtually any area of human activity. In any sector you can think of will have a need for data scientists. A non-exhaustive list of sectors of the economy with job opportunities for data scientists include the pharmaceutical industry, manufacturing, market research, social media, finance, sports, disaster management. In fact, if you need convincing, a search for data science jobs on the internet will return hundreds of live jobs out, even during these difficult times. If interested, you can even consider doing research in data science or any cognate area, starting with PhD studies. In Bristol, we have a Centre for Doctoral Training focused on data science called Compass. Thank you for listening. You can find out more about our degrees by visiting our website.
Thank you very much. So yeah, this is the presentation from Christoph. And now we're gonna present some the experiences of people that have done a BSc in data science. And also, if you have questions for Christoph and about the BSc, if you can put it on the Slido. We're going to put the number of the that you can need to add in the Slido website, to add your questions, and when we can answer to those questions at the end of this event. So today we're going to have Sarah Tyler Knight, she's a data scientist from LB who graduated from UOB studying engineering maths in 2020. She joined the LB team as a research intern last June and has since joined the team full time. Sarah.
Hello everyone, thank you for introducing
joining
me.
us.
Thank you. I'm just going to share my screen. So me and a couple of colleagues from LV are just going to talk to you a little bit about my experience actually joining the team and give you an idea of what it is that we look for as a team when we are hiring, to give you an idea of some of the skills that we find really, really useful in the data science space. So let me know if this is sharing successfully.
Yep.
Great. So again, thank you guys for having us. Really, really happy and excited to be talking at this event. And so yeah, I'm Sarah and I'm one of the data scientists on the team, but I had a slightly maybe not typical route into data science, and that was actually studying engineering. Now, I was really interested in engineering when I was a kid. I had like introduction to it from my parents, and I really liked essentially taking things apart and trying and sometimes failing to put them back together again. So when I was looking at routes after school, I discovered the engineering maths course at the University of Bristol, which really caught my attention. And I really, really enjoyed it and joined in 2016. One of the highlights for me when I was working through my degree was the idea of having modeling-based projects. So it's one of the big sales points for the engineering maths course, with having real-world problems that we use all of our maths skills to try and tackle, develop an understanding, and find a solution. Now, this is something that's definitely quite engineering, but it was through this that I discovered data science. It's not something I'd ever heard of before. Data science BScs weren't really on the radar when I was looking at university. But during my time on my engineering maths course, I discovered that data science problem solving is a really great concentration of all the things I really loved about my degree. It gives you the space to explore new ideas, using all of the tools at your disposal, but also tackling something that is new. You know, you're always on the kind of edge of either technology or using data science in areas that have never been used before because it's such a new growing field. Now, as Patricia mentioned, I joined as a research intern, and that was really exciting for me because it was the epitome of being at the cutting edge. I, along with my kind of supervisor from the team, we were looking at something called conformal predictors. Now, they are something that is very, very cutting edge. It's not had much research done on it worldwide so far, so it was incredibly exciting to be working on. I won't go into too much detail about conformal predictors now, but the gist of it was making uncertainty visible. Now, with any data science that you're using, you're making predictions, you are taking in various information that you've gathered and predicting something, whether that will be the price of a car in some cases, weather patterns, financial patterns, whatever it may be, you're making a prediction. But there's a level of uncertainty that comes with the prediction that you're making. My project was about being able to highlight that uncertainty so that you can have an even better understanding of the data science that you're doing and its real world implications, which I found incredibly exciting. As I said, I don't want to talk about it too much right now, but if you have any questions, as Patricia's mentioned, please do drop something in the Slido and I'll be happy to talk about it later. So without further ado, I will pass over to Kaggle, who is another of the data scientists on the LV team, who will be having a bit of a talk to you about what it is that we look for on the data science team. Kaggle.
Yep. Hey, thanks, Sarah. So I'm Kaggle. I guess I should give a bit of self-introductions myself. So I'm a data scientist in LV as well. So I'm Sarah's colleague, and I just completed my degree in University of Bristol in computer science. So today I want to talk about several soft skills which I found very important working as a data scientist. So speaking from experience, I think time management is definitely one of them. So as a data scientist, you need to manage the project timeline, or at the very least, you'll be involved in the project planning. So when you're setting your project plan, you need to take into account of the potential issues which may arise at each stage. For example, you might want to spare a couple more weeks for data preparations because the real-world data is usually quite messy and it's not as straightforward as, for example, the dummy data sets available online. So tidying them up for exploration might take longer than expected. And it's also always better to spare a couple more weeks for that. And with great time management, we could potentially greatly reduce the chance of pushing back the delivery deadlines. And this can help us to slowly build up the trust with the stakeholders. So other than the technical problem-solving skills related to data and machine learning algorithms, sometimes as data scientists, we also need to deal with interpersonal conflicts. For example, you and your colleagues may have a disagreement on how to get the project done or the project timeline, etc. To resolve the issues, you need to do it in a very reasonable way. For example, you may want to explain your reasoning so that he or she can understand your stance better. Or if things got a bit out of hand, you might want to get someone more respectable, more formidable involved as a mediator to assist conversations. Besides that, intellectual curiosity. So it's always good and willing to question everything. Always good to raise your hands when in doubt. And the main reason for that is that when solving the problems, you are very likely to be in a different, solving a very specific set of problems related to that industries. And when you're solving a business problem with the data, chances are you're not going to know it more than the person who comes to you with the data. And you will always be surprised how much it helps with the modeling, especially when you form a deeper understanding of the data at hand by just asking the silly questions. And last but not least, data science was such a wide and broad field. You need to be passionate about learning and experimenting on different machine learning techniques. More often than not, you'll be faced with different modeling problems, which requires different unique sets of knowledge you may not be equipped with. Therefore, you need to be ready to learn while you're working through the problems. And besides, there are also so many novel literature challenging the old algorithms in order to be up to date with the latest development in machine learning models. You just need to be very passionate about it and continuously learning. I think other than the soft skill sides, I think I'll pass to Javi, which will talk you guys through more on the collaborative soft skills.
Thanks, Kaggle. So yeah, just to give a bit of an introduction. So I also am a data scientist for the LV team. I studied aerospace engineering at the University of Bristol, worked a couple of years as an engineer, mostly doing data science projects. So I ended up joining the team as a data scientist myself. So to continue with the soft skills topic, most of the time you won't be working alone. So some of the most important skills to build when becoming a data scientist are actually focused on how well you work and communicate with others. So a key collaborative skill, for example, is how well you can communicate the work you have done and explaining the decisions behind the reasoning behind the decisions you took. So in industry, this is done mostly through presentations. So be ready to discuss the work you have done in front of an audience on a regular basis. A key part of this is storytelling. So storytelling is a key skill for preparing and delivering presentations. So help you communicate your findings properly and cohesively. This storytelling does not necessarily have to be just verbal. So it's also very important that you can convey the right information through visually, so that's through images, plots, tables. Data visualization skills are a key part of presenting as a data scientist. And because of all of this, in most data science interviews, you will be asked to deliver a presentation. So to build on this skill, your work has to be conveyed effectively to both technical and non-technical audiences. So not everyone that you're presenting to will be an expert in data science or mathematics, for example. So if you can communicate these topics in a simple manner that everyone will understand, then you can keep the audience engaged and better promote the work that you have done. That's in fact one of the most common interview questions I've seen for data science is, for example, describe to me this machine learning model or the statistics concept in layman's terms. Besides from this, a huge part of communication isn't just about getting your message across. If you want to deliver value and insights that will help the business, you will also need to be able to listen carefully to what the business actually needs. So that being their priorities, challenges, and opportunities. You will need to ask the right questions and listen carefully to the responses to make sure that what you're delivering really solves the problems that the organization is facing. And to finish up, you're not only going to communicate your findings, but you're also going to work with people from all sorts of teams and backgrounds. Everyone likes to think that their part in a project is the most important, but in reality, everyone is there because they are needed for the project to succeed. So it's therefore very important that you are respectful and take other people's opinions and thoughts into consideration, even though they might differ from your own or have different priorities to yours. You also have to resolve any conflict you might have through negotiation and compromise. So this will help you strengthen the relationships within the company and also make sure that they actually want to work with you in the future. So that's all from us, I believe. I guess there's... Thank
you so much, Javi.
Yeah.
Just checking, Matteo, are you going to talk today as well?
Yes, I'm ready.
Hi, Matteo. So he's also he's part of the faculty, I guess, of the BSc, and he's gonna give a presentation as well.
Okay, let me share my screen. Okay, can you see my slides?
Yes.
Yeah, okay. So I would like to talk briefly about an application of data science I worked on quite a lot in the last few years, which is forecasting electricity demand. So first of all, why is forecasting electricity demand important? It is important because most of the short-term operations in the electricity industry are based on forecasts. And that is, forecasts are the main input for decisions such as trading electricity, buying and selling electricity on the market, managing the transmission or the distribution grid, and planning production. So each of these operations, you can imagine as a specific cost structure. And what analysts want to do is to minimize the cost, and the cost might be financial, that is related to regulation, for example, the cost of having produced too much or too little, and then there are technological factors to take into account, such as the availability of storage and the cost of generation under different technologies. Now, in the last few years, we have had some developments on the supply side of the industry, which made so that having accurate forecasts of demand has become more important than ever. And the most important development is the increased share of generation from renewable resources. And as you can see on this plot on the left, this is projected to reach 50% of total electricity production by 2035. So this is a welcome change, but on the other hand, this brings about some difficulties. And as you can see on this plot on the right, you see that renewable generation is quite variable because it is highly weather dependent. So here we are plotting generation from wind power and solar power in the UK. So you see that there is a lot of daily and intraday and seasonal variability. So this is a new development because traditionally the uncertainty was coming from the demand side. So the demand was uncertainty, but the production was certain and it was under human control, but it's not true anymore. And then a related development is the fact that fossil fuel plants are being replaced with nuclear plants. And this is important because nuclear plants are less flexible. You can turn on and off production more slowly than you could, for example, with a gas power plant. And this means that adjusting for forecasting errors becomes harder because you don't have anymore the flexibility that a gas-powered plant gave you. So having accurate forecast becomes very important because we have less tolerance to errors. Now, how do we go about forecasting demand? So you can imagine forecasting demand 1 day ahead. Now, demand, if you imagine the old demand for the UK, is driven by a lot of factors. So we can imagine that the demand is going to be some very complex function of time, the time of day, the time of year, temperature, the solar irradiation, and there are thousands probably of factors. But if we want to model it and forecast demand, we need to make some simplifying assumption. So a kind of class of model and the kind of assumption that the models I work with use is the additive assumption, which is quite, in principle, quite simple to explain. So we can imagine that demand is given by the sum of effects of some function of individual variables. So there's going to be an effect. There's going to be an effect of time. There is going to be an effect of the day of the week, of the time of year, temperature, and so on. Plus, in the end, we will have some noise which somewhat captures all the other variables that we haven't observed, we don't know anything about. So this kind of additive model, where we are just summing up the individual effects of different factors, is kind of a much easier model because now we are dealing with functions in just one variable rather than a very complex function of possibly thousands of variables. So if we, such a model can be used to forecast demand for the whole of UK, for example. And here I'm showing you how the effects of some of these variables look like on total UK demand data between 2005 and 2011. So on the top left, we have the effect of time on the demand. You see that the demand here is going down over time. And this is not because over this period, the total demand for electricity in the UK was actually going down, but because here we are forecasting the total demand minus the generation embedded in the grid. For example, generation coming from solar power plants on rooftops. So here, the generation from solar panels, for example, was going up, which means that the net demand that we observe is actually lower. On the top right, we see the effect of temperature. So you see that we have in the UK, at least we have a strong heating effect. So when the temperature is below 20 degrees and a fairly weak cooling effect. So with very little air conditioning actually being used. And on the bottom right, we see the effect of the time of year. So here 0 is the 1st of January, 1 is the 31st of December. And what you see, we have high demand in the winter, lower demand in the summer. And in the UK also, we have a big drop around Christmas when businesses are closed and people leave for holidays. So this is a relatively simple model, but in practice, it can be highly accurate. And in fact, if we use it to forecast the total demand for the UK, for example, it can be up to 95% or more accurate. So it's really a powerful model. Now, talking about kind of new application of data science, we all know that in the UK we are installing smart meters, and the plan is to install them in every home. And now we want to do something useful with the data. And one thing that we might want to do is to forecast the demand, not anymore for a whole country, but house by house, 1 day ahead. Now, this is quite challenging. And the reason for this is, if you look at this plot on the top left, here on the horizontal axis, we have the time of day going from midnight to 11:30. And here you see the total demand for a portfolio of around over 2,000 households. And every curve that you see here is the demand over 1 day. So what is clear here is that the demand has a kind of repeatable pattern. There is a one peak when people wake up, one kind of in the middle of the afternoon, and then there is the big evening peak when people get home. So forecasting this demand could be done using the methods I described before, and which rely on this kind of repeatable and kind of smooth daily pattern. But then when we go down to smaller aggregates, so we go down, for example, to 50 customers, we see that we have more noise because we are averaging our data over fewer households. And if we go on the bottom left, we have 10 customers. So here, really a big amount of noise compared to the information we actually have. And if you go down to the bottom right, you see that this is the demand of just one customer, and you see that it's extremely noisy. We have very high peaks. So this is going to be really challenging to forecast. Okay, so this is close to the kind of application we are looking at now. And you might wonder, okay, why would we want to forecast individual demand? And one answer is that if you can imagine in a few years when there will be lots of electric vehicles in circulation, we don't want to get into a situation where everybody gets home at 5:30 and plug in their vehicle and start loading it at full power, because that will cause disruptions. So we need to have automated management system in place in the grid, and these systems will need to rely on forecasts that are aimed at each household. Okay, so here to conclude, if you found this kind of application interested, you might ask how should I prepare to be ready to work on this field? And in particular, you might ask, do I need to know a lot of math to work on this? And my answer would be yes, you need to know quite a lot of math. Of course, you don't need to know the whole of math, but you need to know the part of math that are provided by the data science BSc that Bristol is offering. And in particular, if we look at year one, we have some foundational units such as probability and statistics, matrix algebra and linear models. So these are the kind of basic building blocks that then will allow you to build up and get closer to real world data science applications. In year two, we start looking at more kind of complex models and algorithms. And then by year three, we start looking at linear and generalized linear models, time series analysis. So by that stage, you will start really to understand the kind of model, this kind of additive models I was talking about. You will be able to use them. You will be able to potentially improve them. And then this is not enough. You also need to have good computational and programming skills to be effective in data science. In particular, if we look back at this kind of applications, imagine you have data from 20 million smart meters. So this means that every hour we have 20 million observations coming in, because we sample hour by hour. So in one day you have 20 million observations times 24, and then you multiply that by 365, and you see that quite quickly you start dealing with hundreds of millions of data points. So to manage that kind of complexity and to be effective, you need to have good programming skills. And the data science program will be able to equip you for that. And in particular, if you look at year one, we have an introduction to scientific computing. And importantly, also algorithm and programming in R and C++, C++ being a very efficient language to implement really fast models. And then the program builds on up using via intermediate scientific computing and then advanced scientific computing. So by the end of the program, you should really be equipped to be an effective data scientist. Okay, that's all for me.
Thank you very much, Matteo and Sarah, Javi, and Cor. And so, yeah, thank you. And Christoph, I don't know, well, all the team actually, we have a few questions from the attendees. So I will direct the questions to all of you. And if one of you wants to answer, that'd be great. So one of the questions is, real world data sets tend to need wrangling, validation, quality control. Is there any dedicated training in this topic integrated into data science BSc program? Christoph, I don't know if you want to.
So I guess this one is for me. So of course you're absolutely right, Emma. So there's no specific course to do this kind of things, but all our units, and in particular all the new units that we've prepared for this BSc in data science, involved weekly or sometimes bi-weekly computer labs, because we wanted the students to put the theory into practice and be confronted with data. And somehow most of the training in data wrangling in the first year will take place in those computer labs. Then in the third year, of course, there will be a project, and project with some external partners or not. And of course, this will involve some training in this area. And of course, if you choose to go with a year in industry option during year 3, then there's no doubt that you will be exposed to the issue of data wrangling in the real world. So I don't know if the people from LV or Matteo have got something to add to this.
So yeah, coming from LV's side, there is a lot of data wrangling that goes on. As we mentioned, there's unfortunately none of the data sets that you will be using in real life are as nice as the ones that you kind of use when you're, trying something out on Kaggle. But yeah, it's one of those skills that you really do pick up as you're working on projects, as you're getting that kind of experience. So it's a very, very powerful tool to be able to get good at, but it's also one that you really do learn with experience.
And Sarah, could you tell people maybe they are interested in, they might not know what Kaggle is?
Oh, yes, of course. So Kaggle is a really, really great resource if you're interested in data science. So it is a website that has loads and loads of different data sets. Some of them are very clean. So there is something called the Titanic data set, which is one of the kind of staples of data science. It's all about who survived to Titanic sinking and who didn't, and things like their gender, their age, I believe it's got their career, things like that. But then there's also some fairly messy data sets. And Kaggle also has a section on the website dedicated to competitions and challenges. So if you want to kind of see what data science is about, it's a really good place to check out work that other people have done or get some inspiration for yourself. So maybe if you go on Kaggle, have a look at the Titanic data set and see what other people have done with it and get your teeth into it as well.
Thank you so much, Sarah. And actually, another questions for you and Javi and Cahor. What platforms do you use when you are using data pipelines, and what is your favorite?
Oh, I think that might be Javi.
I'm here. Yeah.
You go.
Okay. So I think for our data science team, we do have data engineers to deal with a lot of pipelines and deployment of the models. So I think due to our natures of the business, we are using Azure because we are due to a lot of privacy, data privacies and confidential issues. And yeah.
Okay.
So it's probably to quickly mention, not every company will do this, but LV, we have data scientists and we have data engineers. So as the data scientists, we will be responsible for building the models, making sure that the models that we're generating match up with what the stakeholders need. The data engineers are responsible for more of the making sure that we ingest the right data from the right places and then putting those actual pipelines into final production. So yeah, some places you'll be doing both, but we have quite a clear split with LV, but we're always working side by side with the data engineers.
Right. Thank you, Sarah.
Yeah, and if I may add,
sorry.
Just very briefly, at the level of the BSc and data science, you might be interested in the sort of programming languages that are taught. And basically, we focus primarily on R, which is a well-known statistical language, which has the interest in the advantage that it comes with many libraries. But we also have a big focus on Python, of course, because it is the language of data science at the moment. And there's a bit of also of training in more in an older but more classical language in C, because sometimes you've got to use C in order to speed up things, for example. So there's quite comprehensive training in the relevant languages that are needed in data science.
And a question maybe for you or Matteo, what are the emerging and hot topics that are being taught on the BSc?
Yeah, so maybe I'll start. And so first, of course, it depends on what you mean by hot, but basically in the first 2 years. So, and I think Matteo expressed that in his last slide. So basically, in the first year, we really teach the foundations, the foundational mathematics that underpins data science, and then basically progressively from year 2, basically we start teaching modern techniques that are, you know, for example, used in machine learning. But of course, you're not doing learning things that are really cutting edge in the sense of being what people are working on at a research level. But from year 2, you're taught some machine learning techniques. And of course, I got to drop the name neural networks. They start to be mentioned in year 2, and of course in year 3 there are many more options, you know, including a unit in financial mathematics, if this is what you find exciting. And since actually the video was recorded, there's been a new development. That is, we are currently developing a 3rd-year machine learning techniques, which will be deployed in time for the first cohort to take that unit, which of course will include all the standard modern machine learning techniques that you may have heard of. So basically, the bottom line is that the focus is primarily on teaching you the mathematics and the mathematics that are relevant to data science, and that involves a lot of mathematics, which usually is not put together in a coherent manner, and this is what we've tried to do. And basically, we bring you progressively towards the hottest topic. And if you choose to do so, there's the possibility of doing a PhD after your studies. So in Bristol, we've got a Center for Doctoral Training in Computational Statistics, which is perhaps another word for data science, but of course you can do such a PhD elsewhere. And then, of course, as part of the program, we will try to expose the students to many of the applications of data science, and you may find that to be something that is of interest, and that could include, you know, climate change, just to name an easy one.
I have a final question, if I may. What do you teach about ethics and responsible innovation and research?
Yeah, so in year 2, we've got a unit specifically dedicated to this, where basically all these issues surrounding the ethics of using and working with the data will be considered. So that's part of the program.
Okay. Great. We have a couple more questions, but I think we have to stop now. But thank you so much, Christoph, Sarah, Javi, Matteo, Kaggle. It's been a really interesting session, and I hope it has been really informative for the attendees. And I wish you well on the BSc coming up. It's going to be really exciting to have all these new students arriving at Bristol. And if you need any support and help, the Jean Golding Institute is here, and to connect you with other students across the university as well. So thank you again, and hope to see you in our networking session later today at 1 p.m. Bye for now. Bye, and thanks
for having us.
Bye. Thank you. Bye.
Thank you so much. Bye.
Bye.